All right. Anyway, so first of all, so I'm Alfonso Amayuelas. I'm a machine learning engineer at BigML. BigML is a half American, half Spanish company that's been working split between the two continents for all this time. And our goal is to democratize machine learning. So my talk today is going to be first about what machine learning is. I want to demystify what machine learning is and why we confuse it sometimes with artificial intelligence, all of that. And then I'll give you a couple of examples of what we do in my company. And at the end, since this is a skills sharing event, I want to show you how easy it is to use machine learning and how you could be using it in just a couple of minutes. All right. Now. All right, now, so yeah, this is me. I'm from northern Spain. I've been living here for 2 years. This is a little bit of my experience. Mainly what I like to say is that I like applying machine learning to like real world tasks. And I'm also focusing on research and knowledge representation and how we use a data structure that we use, that we call graphs for artificial intelligence, but you can ask me more about that later. Anyway, so let me start by the history of computing. So many years ago, we used to have this, which is punch cards, and that's how we used to program the old computers that used to fill a whole room. Then later, it came to the 1980s, 1990s, when we were able to just code on our laptops, and that was the time when C++ and Java started to become popular. And now this is the time when we are. Yeah. Sorry about that. Okay. So this is our time now when we are starting to use data. Companies are gathering large amounts of data, and this is the time in the 2010s when we are starting to apply it. And let me explain how we make our programs learn from data. So the general definition of machine learning is a set of algorithms that learn from experience and data. How do we do that? So first of all, we create a program, an algorithm. We have an input of data. We put that all together in our computers, and we extract the statistics from the data. So mainly the algorithms are not really learning something new, but they are extracting the main statistics from the data that they are given, and then they extrapolate that to new examples, and that's when we take actions, and when we use it for the machine learning applications that you might be used to, like object detection, spam detection, natural language understanding, or even translation. And that's what we use all the time. But you might be wondering, okay, why is this so popular now? So the machine learning is something that's been studied for 5 or 6 decades in academia, but it is becoming really popular. You've seen that on the news all the time. And the only reason why this is becoming so popular now is because it's the time when the computer power that we have available to our engineers is really the amount of computing power that we need for these tasks. We also have cheap storing, which means that we can store massive amounts of data. And also we have an explosion of data available from the internet. So all those three things combined together have allowed us to do machine learning as we are doing today. And it is the moment when we can start applying this to real world applications and to real businesses. And that's what we do at BigML. So first of all, I also wanted to clear the air between artificial intelligence, machine learning, and deep learning, right? Because this is all buzzwords that you've all heard in the news. And well, artificial intelligence, we call it, it's like a large branch of science whose goal is to try to replicate human intelligence. And within these tasks, you have computer vision, you have natural language processing, language understanding, you have knowledge representation. Then within artificial intelligence, we have this branch, which is machine learning. And it's what I explained to you right now, is it's a set of algorithms that learn from data. And then within machine learning, we have deep learning, which is the kind of algorithms within machine learning that that use neural networks, and they just need large amounts of data to be trained, usually. So another thing that I wanted to say about AI is that, well, we've seen all in the media, and I think it's about time to demystify it. So most of the times when I read the news, I read news like this saying, AI is mastering language, should we trust what it says? Or artificial intelligence is creating a new world order, things like that. But to be fair, and as I said to you, it's just algorithms that are learning from data, and they are just as good as the data they are given. And they are not like gonna revolutionize the whole thing, or it's not gonna happen like in the Hollywood movies that we're used to in science fiction. There's a reason why they're science fiction. Hollywood is doing a great work on this, but I believe that we are many decades or many ages away from being able to achieve this kind of robots. So now, let me just explain what BigML is. We are a business that was born about 10 years ago in between some scientists in Barcelona and Oregon in the US, in the West Coast. And their goal was to, back at the time, like 10 years ago, their goal was to democratize this and let everyone use machine learning. Not only if you're an engineer, because like the tools that we are using for machine learning, they're made by engineers for engineers, so you usually need to know how to code to be able to use them. And their goal is to use this, to create this platform for everyone to use it, and you just use it as you are used to using Google Docs. You sign up and start to upload your data, and you can train your models. It's another service that is available for you on the web. So mainly what you do is, as I said, you upload your data, get your features, train your model, and every time you give a new sample, you make your prediction or whatever you want to do. I don't know how many engineers we have in the room right now. Can you raise your hands? Yeah. So I believe that it's not really important how hard it is to use machine learning, but what we are doing here is, yeah, so mainly we need to define the task. That's sometimes it's hard. Then we do all this data wrangling and clearing the data. That's usually, people don't pay a lot of attention to that, but to our experience, this is what we spend most of the time on. And finally, we train the algorithm, we check the results, and that's also another important part of our work. And we redo this many times until the results are good enough. So yeah, why BigML? As I said, it's a time when the tools that we have in the computer power are just matching up, and we're able to apply it to real-world applications, and that's what we are doing right now. Not only people can sign up on the platform, but we're also deploying all these applications to the world. And I want to make a comment about that afterwards. So yeah, the BigML Pass has been for 10 years. We've worked with a lot of many companies. It's been growing in a number of users. We've worked with some of the biggest companies like Dutch banks, the US Air Force, and we've just reached last year 150,000 registered customers. So that's like a lot. And we are deploying, as I said, those applications to the world. We are building those applications with some of our partners, both in Europe and the US. And yeah, we have a lot of users, patents granted. We have even more patents coming up this year. And we are deploying every day. I don't know if there is a data of how many models we're deploying every day. No. Okay, never mind. But we're a small team working from everywhere, and that's the cool thing about it. We have a really remote culture. We are located, I'm here in the Canary Islands, I'm the only one, but we are located in Spain, the UK, the US, and China, I think. And then some people are just traveling around. So I want to comment about a couple of use cases. This is one of them. This is for an infrastructure company in the US. And mainly they wanted to have dynamic pricing on the tolls on the highways. So they wanted to they wanted to optimize the amount of money they get for the lanes they have. And for that, you need to, and they also wanted to charge the cars automatically every time you get on. So they wanted to remove the tolls from the highways. And they just had some cameras on every entrance on the motorway. And whenever a car is coming in, they check the license plate. They also check the occupancy of the motorway, and they compute the best price for the time that they are using it. And even if you think license plate is an easy thing, it's not an easy thing to do in the US, because here we all have the same license plates. In the US, they have different kind of license plate for every state, but then you can also pay extra. It's the US, remember that. So you can pay extra to get your own license plates. So you mainly can have, you have like all sorts of license plates, and that's already a hard thing to do. And then we have to deploy a lot of models to be able to compute those optimal prices. And that's one thing that we did. But then this is another project that I really liked. This is Off-Grid Electric. This is a company in Africa that is deploying solar panels to remote places in the middle of nowhere in Africa. I mean, like, not the middle of nowhere, but like in the middle of, yeah, in the middle of nowhere, whatever. And the only problem is that whenever a subscriber wants to say goodbye to the company, they need to send someone to pick the solar panels, to uninstall the grid they installed. So it's really expensive when a subscriber wants to end their relationship with the company. So they said, what if we have a system that knows when a subscriber wants to terminate their contract with us? And that's when they called us at BigML, and they say, and they asked us to deploy this prediction system to know when, with the data they had, to know when they're gonna unsubscribe from the system, so they could offer them some discounts and yeah, retain those customers. So it was actually cheaper to offer those customers a discount than it is for them to send someone to pick up the whole system they've supplied them. And since this is a skill sharing event, I wanted to show you how easy it is to do this. So yeah, let me go for that. This is our platform. You can see it, right? Okay, so I'm gonna do that same example on a telecom provider data in Iran. Yeah, Iran, whatever. It's the data that I had available. So here we have those that data. I uploaded the file. This is a CSV file. I uploaded that data with area codes, phone number, whether they have subscribed international plan or not, how many voice messages they've sent, whatever. And then we just have to train a model on this one-click. No, sorry. We have to click on one-click data sets. We have it here. So here we have some statistics already for our data sets. Then we go to train and test. And once we have our thing divided, we just train a model to try to predict if the system, if people are gonna drop or not. So we trained an algorithm that's called a random forest. And so here we can see things like, okay, total day charge, and like if it's below 39.83, then this happens, and then you go, you proceed on this kind of on this kind of decision trees, and you get all these rules, and this is one of the simplest algorithms, obviously. then what we usually do is go for, okay. So we train our algorithms, then we check our results on the test sets, and just like that, we were able to predict whether someone is going to drop from our service with an accuracy of 96%, which is like really high. On the data set that I had, we could predict if someone is going to drop or not. You're like, okay, that's cool. Maybe the data, it's already, maybe not. The data is already prepared for me to give you these good results. But we also have some other cool examples, like spam detectors, right? Like a lot of the time, we're all using emails, SMS, voice calls, and all of those systems, they use machine learning to test those spam, to train spam detectors, and they use tools like these ones to do that. So, for example, I did that for SMS, for text messages here. And you're like, okay, if I don't say anything, it's probably gonna be Han, so it's a good message. But if I write something like, you see how it becomes a spam. So just like that, our model is able to say, okay, this looks more like a spam or not. And you're like, okay, this is cool, but it's a spam detector that we use on Google or Yahoo all the time. Just the same way, the good thing about a BigML platform is that in the same way that you train these simple models, you can train more complicated models. So I also downloaded yesterday this X-rays from a hospital that is available on the internet, and you see these images, and you're like, okay, they are just chest X-rays, and I'm not able to tell you whether there is some complication here. Maybe a doctor can, but I cannot. And just in that way, there was a doctor before that checked all those pictures and said, okay, these are images of pneumonia. And yeah, like, honestly, I don't see the difference. But I uploaded all of this to our system. And just like that, with a 98.44 prediction, obviously it was a more complex model than the one that I just showed to you. But with a 98% prediction, we're able to tell, the system is able to tell you whether this was pneumonia or not. And, well, yeah. You can see it there. And that's how easy it is to use machine learning on BigML. I don't know if I solved any of your questions. Let me just make a couple of comments on the presentation. Okay, I had this ready. I thought that maybe someone was going to bring their laptops. I had this ready for you to do it, but I don't see many people with their laptops. I just wanted to say a couple of comments on Spain AI, which is it's an organization located all over Spain. They organize these great webinars, and they do interviews to really to really important people in the country, and they try to disseminate the importance and artificial intelligence within Spain and the Spanish community. So if you're really interested about the topic, I really encourage you to check this out. And that's been all from me. If you guys have any question. Yeah.
How do you do parameter optimization? Because that's usually the part that takes the longest. How do you get the most functional?
So we do have an engineer here. So yeah, that's actually, as I was saying in my presentation, that's what takes most of the time. But there is what we call, I don't know if you've heard about this, OptimiML, which is it's a set of models that their goal is to optimize the parameters. So we have this deployed in our platform. You just go there, train this OptimiML, and it checks for the best model within the whole range of algorithms that we have, and then it checks for the best parameters. and gives you the best results. Obviously it takes way longer. That's actually what I use for the pneumonia example that I gave you. So while the simplest model, it took like 10 seconds for me to train, those kind of models take for hours to train. I don't know, just depends on how good you want to get. You need to train it for longer or not. Right. So that's another, that's another part. So as we were saying, what we want to do is make this easy for everyone. And we know that, as I showed to you before, 70% of the time in a data science project or a machine learning projects are usually spent on data wrangling and clearing your data, and that's part of it. So we've deployed a lot of kind of smart systems to be able to recognize that. But even if we're unable to do that, you can always choose which parameter you wanna add or which format it is in. Because like for example, there is this thing about dates. Dates in America are written as month, day, and year. But here in Europe, we use year, month, and day. Day, month, and year. So that already becomes really complicated when you have data that's coming from the US and from Europe. So even our system is able to recognize which kind of date format you're using. But also one of the purposes of the platform is to make the whole workflow easy. So we have a lot of scripting. We actually have our own scripting language. If you wanna format your data in some way and then like automate the whole workflow, so that whenever you're bringing your data to the platform, you're always doing that in the same way. So yeah, it's a whole thing about automating the whole process. What do you mean? If we? So it depends. There are some companies, big companies that contact us, and I'm actually part of that team that whenever a big corporation is calling us, usually that's the only problem. We are a very small team. We're about 50, 60 people at the moment. And we do offer those kind of services. It's kind of more of consulting services. But yeah, they have to pay some extra money for that. And yeah, we do offer them. Yeah, exactly. Yeah. Listen over there. So as of now, we do not check those kind of things. And it's more about the person that's training these models that should be putting the ethics to what he's planning to do, right? I mean, this is part of a whole thing about ethics in AI, and that's something that now is being taught even when you're doing an engineering degree. Because like before, when I did computer science some years ago, not even that many years ago, I never actually had it. No, I did have an ethics class, but we hardly spoke about the problems about AI. And I believe that now they're including a lot of ethics courses, and yeah. But no, we do not check those kind of things at the moment. Of reinforcement learning, as I believe, no, we don't have that at the moment. So we have supervised and supervised learning. We're deploying now, we also have natural language processing, and we're deploying now image detection, but we do not have reinforcement learning because the goal of this platform is to make it available for everyone to use. So we just make the features that most people are going to be using. Like, it's reinforcement learning at the moment is something that's still in academia probably, and very few, like very few people are using them in industry and deploying their systems to the wild. So, no more questions? Yeah. We do use an agile system, but it's a split in between the groups that are working on the platform. Like, we have some teams that are just deploying new features to our platform. We have a few other teams that are working on what we call the frontier applications, which is what I'm working on. We usually, like, when someone asks about if we have consulting services, what we usually do, or what our management system does, is just going for the projects that are not really implemented on the platform yet, and are the next features for our platform. And then what we do is we implement that project for the company, and then we try to integrate that to our platform. That way, the platform keeps growing with the new applications that are coming out from the market. Yeah. I'm afraid I'm not allowed to disclose that information. Yeah. What kind of features we were using from the African electric company for training our models, but yeah, I'm not allowed to say that. That's it? No more questions? Okay. Yeah, sorry. So he's asking for the language that we've used for implementing the platform, and the backend is implemented in Python. Well, I think all of it is implemented in Python. So we use Django as a backend. Yeah. What do you mean? Yeah, that's a good thing about the platform. So you can upload 1 megabyte file, and you could upload tomorrow 10 gigabytes, and it's gonna work the same way. So I'm not in the distributed systems team, and I actually don't like that kind of part. But like even the algorithms that we use, they are implemented in a distributed manner so that when you upload all your data, it works perfectly. So yeah, that's a good thing about the platform. You upload a 15 megabytes CSV file, and it works. And then, as we do in our projects, we upload gigabytes of data, and it works just the same way. And that's the cool thing about it. Okay. I had on the slide about that, but I removed it because I thought that it was not going to be interesting. But mainly, what we're doing now is implementing the object detection features, and we are actually announcing that in a few months. Then we are implementing what was it? Like all the platform that you've seen now, but with a UI that you can just drag and drop the models. And then the next step is implementing, like what we're doing right now for implementing projects to other companies, make that available for everyone, and just using a UI where you can just drag and drop your websites and creating simple websites with our models. And yeah, so the whole idea about the company is to democratize machine learning, so that even if you're not an engineer, you could just like log in, upload your data, train your model, and then drag and drop your user interface, and you have a website running with all the models running as well. Yeah. Yeah, go for it. Yeah, they are one of the greatest competitors out there, I guess. As far as I know, I do know that they use similar in like the big tech companies, Facebook, and as far as I know, Facebook and Google, they use internal services like this one within their employees, and I believe that what Google is doing right now, because I don't know which service are you referring to. Right, right. But that's just like a simple binary classifier. Is there a name for it? Is there a name for that? 'Cause yeah, no, because all I know from both, like all the big corporations, Microsoft Azure, O's in Amazon, and Google Clouds, they're deploying these kind of systems, but usually they're deploying these systems for engineers. And yeah, you need to be an engineer, like most of the times, you need to be an engineer that knows how to code and how to use these systems for you to use it. And our idea is to try to deploy this to the wild so that anyone can use it. And we actually do, we have a whole education team that goes to other companies that are buying licenses, and we train their employees. So the actual idea of our founder is to try to think about this platform as a lot of companies are using Excel right now. Like Excel is everywhere, and kind of the idea is to try to be able to use that in the same way. I don't know if there's going to be a time when it gets to that, but yeah, it's kind of that. Like, you open the tab, you get machine learning, you know?
So with sustainability becoming a bigger thing, and I've heard that machine learning and all that computing power is taking quite a bit of energy.
We spend a lot of energy training these models, yeah. Yeah, no, like all of this is running, so like the one you're seeing is running on the clouds, and yeah, just the, it's part of the cloud provider's problem to try to make that energy clean. But yeah, as far as I know, we also have a couple of projects on trying to use algorithms that spend less time training, and therefore we spend less energy. But yeah, the main thing about spending less or being more electricity, what do you call that? Efficient? Yeah, being more efficient on the power that we use is using algorithms that train for less time, and that's why you probably heard about these other buzzy words. What was it? Big data. Yeah, sorry, big data, and that was when a lot of machine learning, they were like, okay, let's try to get more data and train for longer time. And what we are realizing both in industry and in academia is that we should not try to get more and more data, but rather to try to make the algorithms work with less data. Because otherwise we're seeing, like, I don't know if you heard about this on the news, they are big language models, I think they're called, and they are trained for a very long time, like really long time, for months. And they have millions and billions of parameters, and yeah, they spend a lot of electricity on that. It's becoming more and more expensive every day. Yeah, even in our platform. So like, you've seen that if you train the simplest model, it takes a few seconds to train. If you want to train the most complex one, I've left it running for overnight, and it still hasn't finished. Yeah. So yeah, that's a good thing. That's a good thing about the platform again. You've seen the spam detector. That's already a running. That's already a running example, and you could just connect to it through an API, and you could be sending queries to it. At the same time, we know that a lot of the times in the wild, you don't have internet connection, so you can also download the trained model, install it on whatever device you want to install it, and query to that model. Yeah, so like, you can run it on the cloud, you can run it on your computer, or you can even run it. We've also implemented versions of the models that are much smaller in size, so that you can install it in mobile phones or whatever. Yeah. Go for it. This is, just for the record, this is a physicist, all right? He's not an engineer. Can you say that again? Yeah. Yeah. So you actually download the train model. Yeah. There's no need for an approximation for it. Right. So it depends. Yeah, no, I mean, you download the parameters and the model. Yeah, exactly. Yeah, exactly. And then we've used, because we realized that some of these models are huge, so we even use some kind of optimization for trying to reduce the size of the models. So we have like a system to try to reduce that. Yeah. Exactly, yeah. That's it, yeah. No more questions? The Italian guy over there? Okay. That's it.
Okay, well, thank you very much for your presentation. So we've just had the first part of the event, and we're going to start the second part, which is called Meaningful Conversations or just Conversations. And what we're going to do is we're going to tie it to the theme. So it's going to be about machine learning, and we're going to make groups. We're going to make groups of about 5 people. I think we're with about 30 people, so just try to sit down at different tables. And the question that we want you to discuss is, to what can we apply machine learning in the future? So what kind of applications, real-world applications, can you think of that we can apply this to? Okay, that's it. And then just make the groups. I think make a group up there, one here, there, up. I think each table one. 5 people per group.